A very warm welcome to our next presentation. Peatland protection is climate protection. What could the future of agriculture on peatland look like? My name is Fietje from Fridays for Future from Greifswald, and we organized this presentation together with the students of Rostock. I would like to thank you for the collaboration. If you have any questions during the presentation, you can use the tweet back. The link is in the YouTube chat. The topic agriculture is really relevant right now, and it's a really important topic this year for climate and biodiversity in the EU, and a special role is attributed to peatlands. And we will hear something about the problem there and possible solutions from Susanne Abel from the Greifswald-Meyer Center. The floor is yours, Susanne. Thank you very much. I will share my screen now. Can you see the presentation? Okay. Okay, let's start. My name is Susanne Abel. I'm a biologist, and I've been working for almost 10 years at the Greifswald-Meyer Center. What is the Greifswald-Meyer Center? The umbrella organization of the peatland activities in Greifswald. There are 3 partners in this center. There's the University of Greifswald, the Michael Suko Stiftung, and Düne e.V. And about 70 people are working together on a topic peatland from different fields. The Greifswald-Meyer Center also has different databases. The GBD, the Global Peatland Database, where we have data on peatland distribution all over the world. We have Pencil, the biggest peatland library worldwide by Hans Joosten, and the DPPP, database of potential paludiculture plants, and More Wissen, so Peatland Knowledge, the website with information on peatlands and climate protection. So we'll start with my presentation. What are peatlands and where are they? And peatlands are all around the world on 4 million square kilometers. And they cover 3% of the land surface of the Earth. So you can see, especially in the Northern Hemisphere, there are a lot of peatlands, but also in tropical regions. So you can say that peatlands are almost everywhere. In some areas, there are more peatlands than in others. So in tropical regions, but also in Southeast Asia, for example. Peatlands are very diverse. Different climatic and biogeographical conditions create a great variety of peatland types. There are also beautiful patterns. You can see the images here. Those are all natural peatlands. The drained peatlands look a bit different. Here you can see the distribution in Germany. They are mostly in the north and in the south. So we have peatlands in the south of Bavaria, close to the Alps, and then also in the northern states, Mecklenburg-Western Pomerania, Schleswig-Holstein, Brandenburg, and then also in Lower Saxony. In total, the organic soils in Germany, so peatlands, because they are classified as having a peat layer of 30 centimeters. So they are also often summarized as organic carbon-rich soils. But our peatlands are mostly drained and only 2% are in their naturally wet state. Here you can see peatland, like a profile of a peatland on the left side of a fen. And the special characteristics in living peatlands is that the production is bigger than the decomposition. So, because there's always a lot of water, the biomass is conserved and is decomposed really slowly. And that's how peat is created and carbon is accumulated. And peat is basically dead plant material. On the left side, you can see sphagnum. It usually grows in raised bogs. And on the right side, you can see a fen. And you can see grasses, and there are also often sedges and reed growing there. And you can see on the right side that there are different layers of peat. In each year, a little bit more biomass is accumulated, so the peatland is growing about 1 millimeter per year. So it's growing really slowly. So peatlands are the most spatially effective carbon reservoirs in the entire terrestrial biosphere. They store more than 500 gigatons carbon in their peat. And that's something that you can't really comprehend, this number, but that's twice as much as all forest biomass, which is on 30% of the world's surface. But carbon in forests is more visible, so it's more present in the minds of people, because you can walk through the forest, but you can't really walk through a peat layer, and that's the difference. Because it's really compact and there's a lot of carbon stored there in minimal space. Because those peat layers can be a few meters thick under the surface. And living non-degraded peatlands can be CO2 sinks in the long term, but only 2% of peatland areas are left in Germany. When we talk about peatlands and the climate, we need to talk about arable land, grassland, forest, and peat extraction on drained peatland. Here I have a good comparison. Peat is like pickled vegetables, like those gherkins you see here. If you remove the water, the organic matter rots away. So that's a good image, I think. And that's how the peat gets oxidized, ends up in the atmosphere. The lower the water level, the more drained the peat is, the higher the greenhouse gas emissions are. So in this case, CO2 emissions. So here for minus 100, minus 80 centimeters depth for the water levels. That's the common peat usage. We have about 30 up to 40 or even more emissions. In the deeply drained grassland on peatland, usually you might not even think that it is peatland, it just looks like grassland. But this is a drained peatland. You can recognize it if you're an expert. And on this field, about 29 tons of CO2 equivalent per hectare per year is emitted, and that is equivalent to 145,000 kilometers driven by car. And that's also dependent on the water level. If it is deeply drained, then there is more emission. And that's also something that has an effect on the products, in this case, milk or cheese. So for the production of 1 liter of milk on peatland, there are emissions that are comparable to 2.4 liters of gasoline. Here we see arable land for potatoes in Bavaria or Lower Saxony, for example, which is cultivated there on peatland, and which is advertised as something really special. And here a high number of emissions is produced. So the emissions are even higher there as on grassland, because usually arable land is drained even deeper than grassland. And through the cultivation of those potatoes on drained peatland, there's more CO2 emitted than is stored through the potatoes. Another negative consequence of peatland drainage is the height loss, because the peat is decomposed, and there's a height loss of 1 to 2 centimeters per year. Sometimes you can see it at buildings, like in this image, or on bridges that are built in peatland. But of course, peatlands near the coast are especially endangered. If we think about rising sea levels because of the climate change, and we also have a lot of infrastructure damages. Roads are broken down, sewers must be renewed, there are damages on houses, because peat is shrinking continuously. In the Netherlands, they have drained in peatlands even quicker. There's been a lot of height loss in some areas. Some areas are 8 meters below sea level, and there are a lot of peatlands in the Netherlands. In the tropical areas, the height loss is happening even quicker because of the high temperatures. What is the peatland use in Germany? You can see the pie chart here. Mainly it's for agricultural use, mainly for grassland, also for arable land. A small part is for peat extraction. So we use the peat as a substrate, for example, in commercial horticulture, for our vegetables and flowers. They're usually cultivated on peat. And one part is also imported from the Baltic countries, but we also extract peat here in Germany. And through the drainage, peatlands are responsible in Germany for more than 5% of the total greenhouse gas emissions. And if we look at agriculture, so the industry, agricultural use and forestry together, then we can see that peatlands are responsible for 37% of greenhouse gas emissions in this sector. So that's a really large number. Also a chance for the climate protection in this area. And we've just gotten the new numbers, and we could see that the numbers are rising. So right now it's 6.7% of the total German greenhouse gas emissions caused by peatland drainages. In Mecklenburg-Western Pomerania, where there are a lot of peatlands, 12.5% of the area are peatlands. Here, the share of emissions is even higher. In total, they are responsible for 30% of all emissions in that federal state. Here, the same image again, the connection between water level and the global warming potential, so the emissions. And here you can see if you re-wet peatlands, you can lower the high greenhouse gas emissions. And here you can see the optimal water level. And that would be a chance for the climate protection to reduce those greenhouse gas emissions. Then there's the question, what about methane after rewetting? Methane is produced in waterlogged rewetted peatlands, so that's really natural for peatlands. Methane has a high climate damage, but it's also much shorter lived than CO2. It stays for 12 years instead of 1,000 years. Methane does not accumulate in the atmosphere like CO2 does. And we only have the choice between CH4 and CO2. And there are models for this. And you can say that the high methane emissions are not as bad as the continuous CO2 emissions through drained peatlands. So quick implementation of rewetting and rise of water levels is mandatory right now. There are also other ecosystem services that are provided by wet peatlands. So you can support the typical peatland biodiversity. In our pilot areas, we can see a lot of endangered species again. So peatlands are really valuable areas. You can reduce the nutrient load, there's water retention, evaporative cooling. So it's also a measure for climate adaptation, and you can stop the height loss. So what do we do with the peatland after rewetting? On the one hand, you can give it to the wet wilderness, so conservation, just leave nature be. You can also do carbon farming, So you can control the water levels for a good climate protection. You can reduce the CO2 emissions. And as a combination, you can do paludiculture, so the productive wet utilization of peatlands. Because after rewetting, the agriculture that we know is not possible there anymore. That's the concept of paludiculture, the wet peatland utilization, so that we can preserve the production function of those peatlands. This word comes from the Latin word palus, which means swamp. It's like a swamp culture. And we have difference between wet meadows and crops. For wet meadows, we use those plants that just grow there naturally after rewetting. And for crops, we are cultivating a special kind of plant in a monoculture to harvest the biomass and use it. Here are a few examples. That's something you might know, the traditional use, cane mowing. Here for reed, there's a lot of demand in Europe. The demand is even greater than the supply. We're importing a lot more than we use here. We have some reed areas that we are harvesting in Germany, but those are just a few. We have an import rate of about 80%. And the reed is imported from China, Hungary, and Romania. But you could also cultivate reed here regionally. Another kind is cattail cultivation. It's a really productive plant, very special characteristics. Here you can see some images of cattail. You can see that it is like a spongy plant. And because of its special tissue, cattail is ideal for building material and also as insulation. There have also already been some developments, but so far there's no large-scale production due to lack of material. So far there's no farmer who has started cultivating cattail in Germany. But there are also reasons for that.
Man kann solche Biomasse von nassen Mooren, also Schilf, Rohrkolben, Nasswiesenbiomasse, halt auch sehr gut auffasern und daraus neue Baustoffe.
You can also use the process of defibration and use reed, cattail, and wet meadow biomass to replace plastic packaging, for example, or for construction material. And these examples that you can see here, they're all made from paludiculture biomass. So there are different ways of utilization, and we are also in exchange with many different companies. And there's a big market growing from this through the promotion of bioeconomy. But we need a higher willingness to pay for this raw material right now, so that it's profitable for the farmers. And the great thing about these products is that they are climate friendly in 3 ways. For one way is that they reduce emissions in the peatlands through rewetting, and through the replacement of fossil fuels and raw material, and then of course that they also replace the material in houses, for example. And we also build a tiny house from paludi materials to show how you can use these materials. In the upper right corner, you can see these panels for the stairs. This is from wet meadow biomass. And then we have a little window where you can look at the materials. And we are doing a roadshow this year in September in northern Germany. So if you look at our website, this is where we will publish our dates for the tour, and you can look at it. You can also use it in an energetic way. For example, directly burn the pellets to produce heat and warmth. And the heat values are similar to wood, but you can also use it via fermentation. You can use biogas and also feed them into existing plants. There's one in Mecklenburg-Vorpommern, where one farmer used wet meadow hay from a rewetted fen and burns it in a heat plant there. And then this heat is fed into the local heat network of the city of Malchin. And there's a reduction of emissions by the avoidance of the emission of the land, and also by the substitution of gas. And currently, this plant is in competition with natural gas without the effect on climate protection being recognized. The central challenge of using rewetted peatland is the harvest. So that's one of the main points why those peatlands were drained in the first place, so that they could be worked with big machinery and to have a stable ground for agriculture. So we need to adapt to this rewetted peatland. And there are different approaches, different to conventional technology. You can, or also the same technology that they used way back when. But you can also use modern bulldozers that have a lot of force, but that can work on these peatlands without damaging them. Another way of paludiculture is sphagnum farming. Sphagnum grows on rewetted raised bogs, for example. This is where we have one pilot land. And we want to use sphagnum to replace the peat that we use in commercial horticulture. And in Germany, we use a lot of peat right now. And we need alternatives for this. And the sphagnum biomass has similar properties to white peat, and it's an ideal replacement for this. In 2016, we had our first large-scale mechanical harvesting of sphagnum, and as of now, we also extended this land to 17 hectares. This is close to Oldenburg in the Hankhauser Moor, Lower Saxony. This is a view from above. So right here it's 14 hectares, but right now we have 17 hectares. And to replace the peat demand in Germany with sphagnum, we need 40,000 hectares to replace the 3 million cubic meters of white peat. And we have a peat phase-out strategy in Germany, and in the strategy also includes alternatives like that, and they're very important for that. And until now, especially in commercial horticulture, they haven't found the best solution yet. And then, of course, the question is if that's profitable for the companies, for the farmers. Right now, you could say yes, it could be profitable, but only if benefiting factors come together. Here you can see the heat plant in Malchin that I talked about earlier. Or for example, with reed workers, this paludiculture could be profitable for them, but you always have to keep in mind that, for example, fodder farms in Mecklenburg-Western Pomerania, without direct payments and without measurements coming from the government, could not cover the costs. And paludiculture is more than just a transformation from carrots to potatoes. There are lots of challenges. It's a new territory. Many rules and laws are not yet adapted to it. For example, direct aid. Then, of course, the topic of use restrictions, because these areas could be nature reserves. And we also have a ban on plowing grassland, which could ban the farmers from plowing the paludiculture and from using it as paludiculture. And so we need adaptations to this. And we are also looking very closely at the Common Agriculture Policy of the EU, because this is the decisive setting of a course. And we also suggest tools for implementing this. We have some publications. If you're interested, you can look at our website and look at the publications. And what's also important for paludiculture is that we need eligibility for aid, and that we need new agricultural and climate measures to promote the raising of water level and have incentives. All in all, there are many challenges for the farmers. It's a huge break with traditions, and the operational structure has to be transformed most of the time, because it's a new way of using the material. They are currently gaining experiences in many pilot projects. Often there's a loss of land value. The value chains are missing. And as you can see on the picture here, and also on the sketch below, there are fragmented ownership structures. And as you can imagine, that the rewetting of these small areas is very difficult, or not possible at all, because it's expensive and difficult to do, because there's also influences on neighboring areas. So you have to think at a district level. You need cooperations and associations so that you can really do it on a large scale and have a practical solution. It's a change of paradigms, and we developed a new profession with the German Association for Landscaping, the so-called peatland climate farmer, which is a farmer who not only identifying themselves with their products, but also with the emission of the reduction of greenhouse gas emission. And this is happening through the increase of water levels or the upkeep of high water levels. And they also need alternative sources of income, for example, with paludiculture, through biomass, and also through the compliance with emission reduction. And then the second question, is it profitable in an economical way? The rewetting of peatlands is a comparatively cheap climate protection measure, which we shouldn't forget. And there are many other positive environmental effects. You stop the height loss, the reduction of nitrogen output, and you have the effects of additional water retention and evaporative cooling. And we have to view agriculture as the solution and not as part of the problem. How can they support this goal? How can they support climate protection? So peatland protection is an opportunity, but also an unavoidable measure. So there can be no Paris without peatlands. If we want to talk about meeting the Paris Agreement goals, we need peatland protection as well. Germany has 1.8 million hectares of peatland and half-bog soil. That means if we want to rewet all of this peatland until 2050, we need to rewet 50,000 hectares per year, which is a very high number. Is that an illusion or maybe naive? If you compare it, for example, with Finland in the 1970s, where they drained 300,000 hectares every year, then why shouldn't we be able to reverse the process as quickly? And also in comparison to that, there's Indonesia, who rewetted 670,000 hectares of peatland in 2017 and 18, so more than Europe in all of its history. We need more acceptance urgently, and we are doing this through knowledge transfer and raising awareness, which we also do at our center with different projects. But peatlands should no longer be shrouded in eerie mystery. There's often the image that you connect peatlands with something that's deadly and that you can sink into them, but we have to think about them in a positive way. And we have to always remember the different important ecosystem services that they can do for us. And wet peatlands have a long tradition and history. And now we have a whole different view on peatlands than we used to have. But this transformation needs to be kicked off right now, because nowadays we know a lot more about it, and we need to accept what we can do with it, and we need to raise awareness within other generations why we view them differently right now. So what can each one of you do? The first question is, you can ask yourselves, do I live in a peatland region? Is there a peatland close to me? How is it used? Because those drained peatlands are not visible most of the time for many people. I made this experience many times, that there are people living in peatland regions and they don't know about that. The second part is that you have to make the emissions of the peatlands visible, to take stock, for example, by taking stock of the greenhouse gas emissions. You can do this by looking at the vegetation, for example. And this is also an opportunity for climate protection that you can highlight by doing this. And the third step would be to talk to municipal representatives about ways to raise water levels by conservation, paludikultur, or recycling opportunities. And the easiest thing to do for everyone, of course, would be to only use peat-free soil and thus protect the peatlands. Currently, we have many pilot areas which are coming into existence worldwide. This is a nice picture of a new cattle cultivation. Maybe there will be one in your region soon. And we will have a field day on the 3rd of September where you can come and look at this project. And yeah, this is a nudge to our website, moorwissen.de and greifswaldmoor.de. Peatlands must be wet immediately. This is our slogan. And yeah, thank you for listening. And looking forward to your questions.
Vielen Dank für den spannenden Vortrag, Susanne. Das ist immer wieder faszinierend, was so alles an diesem Thema dauert.
Thank you, Susanne, for your presentation. I think that's very fascinating. Peatlands seem to be the answer to many questions that the agricultural sector has. Everything is in there, climate protection, for example, but we don't talk about it enough, what you can do in this area. That we need to talk to local representatives and try to re-wet peatlands. So how do I find out if there are peatlands close to me? Is there a kind of overview somewhere? Yeah, we have maps. We put together some maps. This is not a trivial question, actually. And it's not very easy to find out if farmers work on peatlands or mineral soil, but there are some maps at some state authorities, soil maps, and at our center we also created a map of organic soil in Germany, which I showed you in my presentation earlier. And we have very high definition versions online, and you can download them at greifswaldmoor.de, and you can get an image about the distribution of peatlands, and you can see if you live in the peatland region and where the peatlands close to me are. Yeah, great, thank you. This might be a good start to begin. There are no questions right now from the audience, but I have one. So we can see that with climate change, everything gets drier. And how can we even re-wet peatlands if everything is more and more dry? Or is that a futile action? Yeah, that's definitely a question for research and for the scientists. And I don't have the best answer to this question as of now. But we can see that through the continuous draining of peatlands, the water in our landscapes is escaping, and it's even more important to keep wetlands and peatlands wet so that they can serve as a carbon storage. And if we can re-wet all the peatlands as they used to be, that's questionable, but we don't really know that today. Surely there will be peatlands where the water supply is changed so much that we don't have enough water, so that we cannot re-wet them as they are supposed to be wet. There might be many cases of that. So you're gonna see, yes, but at the same time, peatlands are very resilient. There's this phenomenon called the peatland breathing. If you have a living peatland, it builds up everything that it needs to survive. The layer is kind of a buffer for the water storage, so that even in drier times where the water is only getting out in a slow way, and this so those living peatlands, they can take in a lot of water and survive like that. So if you have any more questions, you can write them into the chat. And if you don't, then I have a closing question until we move on. Okay, there's nothing. So one more question from me. Peatlands and agriculture is one of the conflicts of land. And the other conflict is this of renewables, which also need land and space. Is that compatible with peatlands? How can you do this together with the renewables? No, there's not. This should be possible generally. It's very important that if there are new renewables machinery built, that they are built in such a way that the rewetting of peatlands can still happen. And that maybe that's a constructional challenge. That's not really my expertise, but I'm sure there are solutions for that. To use plants, maybe photovoltaic plants that can be built on wet peatlands. It could be a very good win-win situation. And we ourselves wonder why nobody has done that before. because you can protect the climate in two ways there and reduce emissions even more by rewetting peatlands and by using renewables. Yeah, maybe we could raise some awareness with this presentation. Our time is up, unfortunately. And the next presentation that we will have is Changing Seas, How Climate Change Impacts Our Oceans and Why We Should Care, by Anna Friesinger from Kiel, which starts at 7:20 p.m. And I again want to thank you, Susanne, for your presentation, and thank you to everyone who listened. There are many comments on the chat who were very excited about this interesting topic. And yeah, you have the last word. Thank you for listening.